deep neural network performance from algorithm to hardware architecture. But first, the deep learning is the subset of the machine learning. And the last one is the subset of artificial intelligence. The big advantage with the deep learning and a key part in understanding why it's becoming popular is that powered by massive amount of data. The big data era of technology will provide a huge amount of opportunities for new innovation in deep learning. It's predicted that many deep learning applications will affect our life in the near future. Actually, they are already making an impact within the next 5 to 10 years. Deep learning development tools and in surveillance, robotics, security, and so on. The most common algorithm of the deep learning, the first one and the important algorithm called the CNN, convolutional neural network. Is a multi-layer feed-forward neural network that use Perceptron for supervised learning and to analyze data. It's used mainly with the visual data such as images classification. The next, called the RNN, the recurrent neural network, is designed to recognize a data set sequential attribute and use a pattern to predict the next likely scenario. The third one, called the LSTM, is a long short-term memory algorithm, is a type of the RNN that allows deep recurrent network to be trained without making the gradient that update weight become unstable. The other, called the RPM, is the restricted Boltzmann machine, is a probabilistic graphical model. And the last one, called the DBN, Deep Belief Network, is unsupervised probabilistic deep learning algorithm where the network has a generative learning model. This is the most common algorithm inside the deep learning. Because the convolutional neural network is very important algorithm. These algorithm consist of the three main layers: the convolutional layer, pooling layer, and fully connected layer. And the most common CNN architecture, like the AlexNet, VGG, GoogleNet, RiseNet. There are in deep learning there are several tasks like the detection for the cancer, sign, and classification for human, car, cancer, animals, recognition for the gender, eyes, voice, fingerprint tracking for human and vehicle. This is a very famous task for the deep learning. But for the more complex application of the deep learning, like the tag and predictive name on photos, like the Facebook, gradient distributed essay, generating notes from the phone call and analyze it. Deep learning can be applied to any data type. These data type may be private, that collected by ourselves, or public, available on many websites, like the following slide, like the GitHub, Kaggle, Archive. This is very useful links to get the public data set, to get a huge amount of the data set. These more data sets that we collected in our selves or by public or private data set, with the bigger model and more computations, produce the deeper model and better algorithm. These data or these huge or big data that we have collected, we must think how to process these data. The default solution by using the CPU. The CPU is designed as a serial architecture, so they are difficult to achieve this process inside the CPU when we have the real-time processing. So how these architecture to host the processing? The first solution to post the deep learning by using the parallel architecture, like the FPGA or the GPU. FPGA and GPU is the parallel processing architecture, is the hardware card. FPGA is a field programmable gate array. It's a programmable logic device with the higher densities and capable of implementing different functions in a short period of time by taking advantage of parallel processing. While the GPU is a specialist algorithm, electronic circuit designed to rapidly manipulate it and LED memory to accelerate the creation image in a frame buffer inside the our computer. So there are the main key metrics that compare between the GPU and FPGA, like the accuracy, throughput, latency, the power consumption, the cost, flexibility, and scalability. This is the very important table that compare between the GPU, FPGA, and the CPU. In terms of the training for the deep neural network, the GPU is a winner because capabilities are greater. Interference, FPGA, because it has the lower latency, large data analysis, CPU and FPGA. Time latency, FPGA is a winner. Processing and what FPGA, because design can be optimal. Processing cost, GPU and FPGA. Interference, FPGA is a winner because can be implemented many different interfaces. Easy of change, GPU and FPGA. Customization, FPGA is a winner because provide border flexibilities. Size, CPU and FPGA is a winner. And the last one, development, CPU is a winner because the CPU are easier to program than the GPU, both easier than FPGA, because FPGA programmed by the hardware language called the HDL language. At the end, we have some point and summary. It's clear that deep learning application is expanding, as seen in the previous slides. Deep learning configuration combines CPU, GPU, and FPGA to produce a powerful solution. These are the very important summary of the our slides. At the end, thank you for your attention and listening, and any questions.
Okay, any questions? Okay, thank you. Thank you for your presentation.
Thank you. Welcome.
And let's welcome Mikhail to forward his presentation.